So, okay, yeah. Today we're going to talk about just in general what it means to write a program. I give you a problem, like how do you solve it? And then this will be our last lecture on Scratch. We're going to start Python after this in our future programming lectures. So that's exciting. So I'm just going to show you all the last pieces of Scratch that we have not seen yet. It'll be fun. So yeah, let's talk about how to write programs. What does this mean? Like, what do you do if I give you a problem? What happens after that if I don't give you any steps? Like, how do you figure out how to do it? So here's how you might want to break it down. Now, let me fix my pens real quick. Who knows why they're always wrong? There we go. So, okay. You're given a problem, like I give you one, your boss gives you one, who knows. And you want to write a correct version of that program that does the right thing, that performs some task. What do you need to understand before you even start writing code? Well, you have to understand the problem you're asked to solve. That's probably important, right? What are the little pieces? What are the concepts involved in getting this problem right? Concepts involved. What kind of variables do you think you're going to need to use? What kind of blocks do you need? Stuff like that. And then, really, every program under the sun is just a big game of matching inputs to outputs. Like the user gives you something and you spit out some answer based on that input. All right, it's always an input-output game. So the inputs are what does the user give you? Because usually they give you something. What will the user give you? Otherwise, it's a very boring program if it's just the same thing every time it gets run, right? What will the user give you? And then you have to act on that data. Question mark. And then your outputs are what you produce from those inputs. So what is the answer that your program gives back? Maybe it's an animation, maybe it's like a mathematical computation, or it's some number you're trying to produce. But what is the answer? Answer in quotes, because like an animation could be an answer that your program produces. And then once you have all that stuff in your head, then you're ready to write actual programs, write code, drag blocks into Scratch. So after that, you have to come up with some strategy to take your inputs to your outputs. That's always your job. You're going from here to here. You're mapping them, okay? So that's the goal. That's so important. I'll underline them and draw another arrow. You're always going from inputs to outputs in any kind of program. And in general, that's just a program. That's just an algorithm as well. As a sequence of steps to solve a problem. That's pretty much what you're writing. You write a bunch of mini algorithms that maybe come together in the end to make a program. Okay? That's very philosophical. Hopefully it makes enough sense. But like, if I don't give you any instructions and I tell you what I want, this is kind of what you need to think about. Okay? So let's get some practice with those kinds of problems and like thinking about them. Like, here is the problem. How do you calculate the answer? All right, we'll think about it. All right, so let's make a program. We'll use Scratch, of course, today, so we can go to Scratch, scratch.mit.edu, and we'll write our programs in Scratch one last time today. But here's our problem. Here's our first problem. Let's calculate n factorial, where n is some number that we get from the user. So it could have been anything. So maybe the user wanted 5 factorial. First of all, do we know what a factorial is? Hopefully we've all seen this before. It's the exclamation point in math. That's your 5 times 4 times 3 times 2 times 1, right? So I think you can imagine like 4 factorial, 6 factorial, all the differences. It's just multiplying all the numbers from 1 to that number. So that's the problem we're trying to solve. All right, let's break it down into these ideas. So the problem is factorial, but usually you think about input and output first sometimes. So the input, what you're getting from the user, is a number. Like the user is telling you, I would like the factorial of this particular n value, right? So like we'll make an n variable, and it will get loaded with whatever the user wanted the factorial of. Maybe it was 5, maybe it was 500. Who knows? Okay. And then the output, what do we need to produce given the input, is also a number, right? We need to compute 5 factorial, which is like, I think it's 120. And then we need to show that on the screen somehow. That's what the user wanted, all right? So that's the input and how we get it to the output. And then the problem itself is just like doing that process of taking that input number and finding the factorial of it in some way and spitting it back out, okay? So with every problem, you might have little bite-sized pieces that of other problems that live inside of it, and those are called subproblems. So you can make a little mini algorithm to tackle that. So the subproblem that you might think about, like, is, all right, what if the user gives me a bad number? What if the user gives me like a negative number? Like the factorial of negative numbers doesn't exist. What should we do? So that's another problem we'll have to maybe solve. But the original main problem is, well, how do we go and we compute that actual factorial? Okay. So what we're going to do, the way that I'll teach you how, is using a process called accumulation. So we're going to make another variable, and we're going to start it somewhere, and we're going to keep on multiplying into it. Just like we've created sums before. So we made a variable that started at 0, and then we added into it. When we're accumulating into a variable and multiplying into it, we want to, of course, start it at 1, because if it starts at 0, we can keep multiplying something by 0, it's still 0. So we're going to accumulate our results in a loop somehow. Okay, so here's the strategy that I'll show. Let's make two variables. We'll get the n from the user, of course, we already have that. And we'll also make a variable that'll hold our output. I'll call it out. Thank you, excuse me. So that will start at 1 because we're trying to accumulate a number by multiplying. All right, so 1 just starts it off in a nice spot. Okay, so there's that. And yeah, what we're going to do is we're going to keep multiplying n into out. Do you see how n is right now 5? If I multiply that into out, like, it'll become 1 times 5, so that's 5. And then if I just subtract from n, see how it'll get to the next number I need to multiply? So, and then I can just repeatedly multiply n into out as long as n is like bigger than 0. So multiply 4 now into out. That's 5 times 4, that's 20 now. Make n 3. Keep multiplying n into out and decrementing n. 3, multiply 3 into out, that gives you 60. Then you got 2, multiply 2 into out, that gives you 120. Then you got 1, multiply 1 into out. Technically, you could have stopped there, but the answer is 120 still, so that's fine. And then finally, did the multiplication. We decrement n, now n is 0. Oh man, we only might multiply 0 into out. That is wrong. That will make the whole answer 0. So we better stop before we do any more multiplication. So once n is 0, stop, and then we'll output our out variable. All right, so once n is 0, stop. All right, and this will turn into a loop, and we're going to be repeating something until something happens. Remember this? Repeat something until something happens. We're going to need this block eventually, but how long do we want to keep on doing this process of multiplying n into out and decrementing n? As long as it's 5, 4, 3, 2, 1. As long as it's not 0. Right? Once it's 0, stop. So repeat this stuff until n is 0. You see that? I'm going to keep going as long. We keep multiplying as long as n is greater than 0. So the second it's equal to 0, we need to stop. Okay? So that's what we want to do. So once n is 0, so repeat until n is 0, all this stuff. Does that make sense? That's what we'll be doing. So yeah, let's program this. Let's do exactly that. Are there any questions about this setup before I make code about it? You see how I broke down the problem, I figured out what the pieces are going to be. And so, like, if I don't give you full instructions, that's kind of what you have to do. If I just give you what I want. So, all right, when the green flag gets clicked, let's say we're going to need a number from the user. So that'll be in sensing, right? We need to ask, like, what do you want the factorial of? Enter n or something. Enter n and wait. And so the value that we get back from the user is always going to be an answer, but I want to put it into an n variable. So I'll make an n variable for that, all right? I'll go down to my variables section, and I'll change this default one. I'll right-click on it, and I'll just rename it to n, right? Because I needed that one. And so after I get the answer from the user, after this ask block is done, I'm just going to shove whatever answer holds into n. All right, because then now, like, if the user typed 5, then I just placed 5 into n. That's perfect. And I wanted a normal orange variable because those I can actually change. I can't change answer like I'd like to. Okay, that's why we needed that. And then I also want this out variable. Yeah, I want the out variable as well, so I'll make a new variable. Make a variable, call it out for output. And I guess we can check them if you'd like. I'd like to have them checked and displayed on the screen. That totally works. Can I change the order of them? Nope. Okay. So there's that. And at the very start of the program, I like to start out at 1. And n starts out as whatever the user gave me. So I want to initialize out to 1 before I do anything at all, because I'm going to be multiplying into that out variable. And I better start at something I can multiply into. Okay? So, and then what we do is we repeatedly keep multiplying n into out and decrementing n until n is 0. As long as n is greater than 0, we do this. So until n is 0, do this repetition. So repeat until n is 0, because we're going to keep changing n. Repeat until n is equal to 0. It'll make its way down to that. The process of what? Multiplying n into out and decrementing n. So I'm going to need to say multiply n into out. So set out to the multiplication of whatever it was and whatever n is right now. So the very first time, if n was 5, we just multiplied 5 into out. See that? It's taking its old value, which was 1, multiplying 5 into it. And then we want to get ready to do the next number. We want to multiply 4 in next, so I'll decrement from n. I'll change it by -1. So that's going to be the process. And then once we come back, now, like if it was, we just multiplied 5 in, now n is 4. 4 is still not 0, so we're going to continue this this loop body. Remember the term. And we'll multiply 4 into out. Set out to be whatever it was, which is like, now it's maybe 5 or something. We'll multiply the 4 by it and make the 20. So it's like out becomes set out to whatever it is times whatever n is. And now make n 3, so I can multiply 3n, 2n, 1n. And then we subtract to make it 0, and then we stop, because we repeat until that's done. All right? So after that's all finished, we have an answer in our out variable. Out holds the final factorial, which for 5 would be 120. And so let's shout out that answer for 2 seconds. Just say out. I guess technically it's up here if you checked it, but that's fine. So this will be the program. All right? So enter n 5, and bam, it's 120. And if we want to watch this work, like it's doing the right thing, if we want to watch it work, we can add a wait block. We can be like, every time you do something, let's wait a second, then do all this changing stuff. So let's redo this. Enter n. All right. Enter n, let's make it 5, and now we can watch it slowly work, multiplying the 5, the 4 into out, the 3 into out, the 2 into out, the 1 into out. Now n 0, and it stopped. And then we said 120. Does that make sense? Like 4 factorial as well, if I ask for that. It's going to be 4 into out, 3 into out, 2 into out, 1 into out, and now n is 0, that stops our loop. And the answer is 24. Any questions about that code? See how it's doing the right thing? It's counting down from n to 1, and I guess technically from n to 0. And it's multiplying all the valid numbers that we want, that we care about, multiplying into this out variable. All right, so we should also solve this subproblem, because right now, if we ask for the factorial of a negative number, we're just never going to stop, because n is like, it's already less than 0. We're never going to hit 0 now. So if I ask for the factorial of -5, that does not exist, and it's just going to keep on like multiplying -5, -6, -7, because it's going to set and change n by -1. Is it ever going to be 0 if it was already starting less than 0? No. See how this number is just huge? It's actually oscillating, which is cute, because you're multiplying negative numbers. It's oscillating between giant numbers and tiny numbers. So yeah, it'll never stop. So we'll have to click the stop button. So that's another problem we'll need to solve. So the factorial of negative numbers is undefined. Also the factorial of like edge cases, like the factorial of 1 is just 1. Did that work? Yeah, apparently it'll work just fine. And then also the factorial of 0, that should just skip this loop. The factorial of 0 is defined in math to be 1, and it looks like we're doing that right as well. So that's good. But any negative number does not have a factorial, so we should probably watch out for that. All right. So if we get a negative number, if the user gives us a negative number, maybe we should just stop the program. We should yell at the user and stop the program. How about that? So if that answer that we got from the user for their n value, if that was less than 0, let's not even try. So if the answer is negative, then what do? We better shout out at the user, say factorials of negative numbers don't exist. And then we also do not want to continue with any of this code down here because it will never stop. So we better stop the entire program. There's a stop all in control. So if you ever get here, if answer is less than 0, we're going to yell at the user, and then we're going to stop the entire program. Otherwise, if we don't hit the body of this if, it'll just continue as normal. So if we do it right, like enter 5, like it's going to work. It's going to just skip over this if because the answer was not less than 0. It was 5. And then it does the right thing. Otherwise, if I ask for the factorial of like -5 now, it'll say factorials of negative numbers don't exist, and then it just stops the program, which doesn't run us into any kind of trouble, which is nice. Okay, so that was just like us thinking about the problem and like how it's going to be run. We found this like an edge case maybe, and we made sure to fix it. So yeah, any questions about this program? Here it is. Here it is on the screen, a little small. So that's how you write programs. That's how you think about the problem. So let's do some more of this. I'll save this for you. And let's try this one. Let's do some more math, of course. Let's say that this was the problem I threw at you, and that's all I told you. How do you break it down in this style again? All right, so for this example, let's say that I want you to sum the numbers from n1 to n2, where n1 and n2 are both numbers that you got from the user. So for example, if the user said, I want you to sum all the numbers from 2 to 7, they'll type in 2 for n1 and like 7 for n2. And then your job is to compute 2 plus 3 plus 4 plus 5 plus 6 plus 7. Yeah? So that's the job of your program. Now let's break it down further. All right, so what are the inputs, what are the outputs? So the inputs to your program, what's the user giving you to drive your program's execution? They're giving you n1 and n2. All right, they're giving you two numbers, and hopefully the first number is smaller or equal to the second number. All right, you might have to deal with that. And then the output of your program, what do you spit out after you got the input? What do you compute? That is the sum. This big sum all the way from 2 to 7. See that? That's your job now. And then the last piece of the puzzle is like, how do you do it? So what's the actual problem? It's summing from n1 to n2. We have to break that down. Okay. And again, you can break it down into like the main problem of like actually going through and computing the sum. I'll show you one way to do that. It'll be another loop between those values. And then a subproblem is like, what happens if the user says, I would like you to add up all the numbers from 7 to 2 in order. There are no numbers in order from 7 to 2, are there? So we'll have to deal with that somehow. So yeah, we're getting two numbers from the user, like n1 and n2. And we're shoving their answer into there. So like they said, 2 through 7 maybe. And now let's figure out how to actually go and compute that sum. So let's make, again, we want to accumulate, don't we? We want to accumulate a bunch of values. We're going to add stuff, so we want to start it at 0 this time. So we'll make like an output variable that starts at 0, then it'll add a 2 in, then it'll add a 3 in, then a 4, then a 5, then a 6, then a 7. Yeah. So it's very similar to factorial, very similar to the summing problems that I've given you before, but now we have a starting point, a different starting point. So yeah, what we'll do is let's make another out variable. And what we'll do with that is we'll start it at 0 this time because I want to add stuff into it. Okay? We don't want it to like offset anything, so we start at 0. And then here's the game. Do you see that if I repeatedly add in n1, because like that's the first number I want to add, right? 2 all the way to 7. If I work with n1 and just keep on adding n1 and out, that'll put the 2 there. And then the next number I want to add in is the 3. I can just change n1. See that? Just make it bigger. That's the next number I want to add. Add that into out. Now it's 5. Make it 4. Add that into out. See that game? Make it 9. And then make it 5. Increment n1, add it into out. Now it's 14. Make it 6. Add that into out. Make it 20. Make it 7. Add that into out. Now the answer is 27. And then if I make it 8, do you see how I want to stop? Like I only want to go up to 7. N2 is telling me where I stop. See that? And so if n1 ever becomes bigger than n2, I don't want to add anymore. That was the number I didn't want. Did you catch that? That's a strategy. That's one way to do it. If you think about it long enough, that's how I came up with it. So like just keep on adding n1 into out while it's less than or equal to n2. And so the second we want it to stop, then we want to keep on adding it into n1 while it's less than n2, and like increment n1 to be the next number we want. So like first 2, then the 3, then the 4. Keep on going as long as it's less than or equal to n2. So we want to repeat this process until, because we need that block again, we want to repeat until this is not true anymore. So when n1 becomes greater than n2. All right. So repeat until n1 is greater than n2. Because that's a number I didn't want. That's past 7. See that? So that'll stop us. That could stop our loop. All right. So that's going to be the main problem solution. Are there any questions about that? Does that make sense? You ready to see it in code form? All right. So I'll just make a brand new program, and then I'll make 3 variables. I need n1, n2, and out. So I'll rename all those. So the default one can be n1. Then I need n2, and then I want out. Oh gosh, now they're kind of out of order here. I'll move them like this. You can check them if you want. And then out. Cool. Now they're all there displayed. Happy. They exist now. And then what do I need to do? I need to get the inputs first, right? I need to get the inputs from the user and produce the right outputs. So let's get those inputs. So when the green flag gets clicked, what do I want to do? I would like to ask the user for n1. Enter n1. And then I need to shove it into the n1 variable, right? Because right now it's an answer. And I want to be able to change it. So I want to put it in a real orange variable. So set n1 to answer. And then I want to get n2 right after that. So ask enter n2. And then get whatever answer holds and put that into n2 now. See how that'll get those values and put them where they need to go. And then, what's my last piece of initialization? I would like to output stuff eventually. My output variable that I'm accumulating into needs to start at 0. So I'll make my out variable make sure to start at 0 as well. All right, so that's everything's in the right spot now. And then I want to repeatedly do all this stuff. Add n1 into out while it's less than n2, and increment n1. I want to do all that until n1 is bigger than n2, like all the way to 2 through 7. Stop once it's 8. All right, so repeat until. Where's that? It's at the bottom. Repeat until n1 is bigger than n2, because that's when I'm done. So n1 is bigger than n2. But, all right, if that's not true, I want to do some repetition. So what do I want to repeat? I want to add n1 into out and increment n1. Those are the 2 pieces. Like add the 2 in, and then make it 3, so I can add the 3 in next. Add the 3 in, make it 4, so I can add the 4 in next. So, all right, we want to set out to be whatever it was before plus n1. So set out to its current value plus n1. And then I would like to also increment n1 so that I've got the next value ready to be placed in out for the next iteration of the loop, we say. All right, so we'll change n1 by 1 after that. So that'll be the program. And if you want to watch it work, we can do a wait block again. But at the very end, we want to say the answer. The answer is going to sit in the out variable. So let's shout it out. There we go. So we'll say out for 2 seconds. All right, so this will be the main part of the program. Hopefully you can see these are all the relevant pieces at least. So if I run it, enter n1 2, enter n2 7, it really does compute 27. We can watch that work again if we add a wait block into this loop. So like always wait before you do stuff. So I'm getting n1 and n2, 2, 7, and you can see you can watch the 2 being added, 3, the 4 being added, and out 5, 6, 7, n1 becomes 8, and that stops our loop. So we're repeating until that's true. Now it's finally true. So we stop the loop and jump out of it and say the out value for 2 seconds. Okay? Are there any questions about this code? Let's see if I can show it all to you at once. So there it is. Does that make sense? Is it clear how I made it from our game plan on this slide? Because the last piece of the puzzle is, what do we do when n1 is greater than n2? Does like, what if the user says, I would like you to add all the numbers from 7 to 2 in that order? There are no numbers from 7 to 2 in that order, right? So in that case, maybe the right answer is 0. Like, it's up to you, the programmer, to figure this out. What do you want to give back? Do you want to yell at the user, stop the program like we did last time? What happens right now? Is it an infinite loop? Let's see. 7 to 2. It's actually going to skip. It's going to skip the entire loop because 7 is immediately bigger than 2. You see that? And so it will say 0 as the output, and maybe that's right. Maybe that's fine for your program. You see that? It's really up to you, the programmer, if I don't give any extra requirements. So let's just let it do that. I think that's fine. I think that should be empty. There are no numbers between 7 and 2 in ascending order. So maybe the answer is correctly 0, and we're doing that already. That's perfect. Okay. So that's a sub-problem. That's another problem to solve. At least it doesn't lead to an infinite loop this time. Last time it really did. If we gave a bad value, it led to an infinite loop. But this one's okay. Okay. So yeah, I think that's a good enough program. Let me save that for us. Any questions about that one? Dun, dun, dun. All right. So if we're good, here is a problem for you. All right. I would like to give you a few minutes to help each other and make the following program. All right? I would like you to make a program that works like this. I made a GIF of how it should look. I would like you to ask the user for a number greater than 0 and have the scratch cat count up from 1 to that number. So it shows 1, 2, 3, all the way to like whatever these are typed, maybe 10. So I'm saying count up to 10, please. And then he's counting up to 10. But if I typed 5, he should count up to only 5. Does that make sense? That's the program I want you to try. And then before you get started, think about the input, the output, the main problem, any sub-problems that you might run into on the way. And then here, let me give you this code, because it'll be kind of similar. So there's that. If you want to stare at this, I'll make it very small. Oh, there. So there's that code if you want it. But have the scratch cat count up. So what variables do you need? What are you going to get from the user? What are you going to output? Try and figure that out. I'll give you like 5 minutes to think about all that. And help each other. So if the user types 100, you want to print from 1 to 100. We'll leave a wait block for sure. You don't want to like just flash. What happens if the user types count from 1 to negative 10? Do you want to handle that? Do you want to start counting down? Or do you want to yell at the user? It's completely up to you. Give that a try. I think a variable and then change that variable by 1. It's going to be what you're going to repeat, right? That was my timer. Did any questions come up as we tried it? Let me show you how I might think about it. All right, lightning round. Input. We're getting a number from the user, right? That's what we want to count up to. Output. We would like to show numbers from 1 to whatever the user gave me, yeah? And so the problem is just like doing the counting and somehow repeating something. And then I would say a sub-problem would be if the user gives us like a negative number, like or 0, count from 1 to 0, or count from 1 to negative 10. Like what happens? Do you just suddenly be like, oh yeah, sure, I can count down as well as up? Or do you yell at the user? It's up to you. So I think I will use 2 variables. Let's get a number from the user, call it like n or something. We've been saying n a lot. So like if the number that we get from the user is 10, I would like to make another variable, because 10 is like what I want to go up to. Let's make another variable called like counter. That needs to be the first thing I print, right? So it should start at like 1. And then I'll just keep on printing counter and incrementing it. Well, print 1, make it 2, print 2, make it 3, print 3, make it 4, etc. All the way to print 10, because that's the last number I want, make it 11. And I want to keep repeating as long as it's like less than or equal to that value that I care about going up to. See that? The second it gets bigger, though, that's when I want to stop. So repeat all this stuff, repeat like outputting, counter, incrementing it, until it becomes bigger than the number I wanted to go up to. Does that make sense? That's kind of how I might think about it. If that was too many words, let me show it to you in code. Did I save this? Yeah. So I'll be like, okay, user, you give me a number to count up to. What was my prompt? Did I say something special like enter n, enter what number do you want me to count to? Okay, sure. What number do you want me to count to? And so we're getting into answer, whatever that was, and I have apparently decided to use n and counter as my variables. So I'll call this n, and I'll make a new variable called counter. And I will set n to be the answer. That's what I want to count up to. I guess technically I could keep calling it answer. It's fine. And then I want to set counter to 1 because that's the first number I want to start with. Count from 1 to that number. All right. Set counter to 1. And let's say we want to only count up. Let's say that. So I want to repeatedly print counter. So like I want to print whatever counter is, that's the 1. And then I want to make it 2, right? So I want to say the value of counter. Like that's going to print the 1 the first time, let's say for like 1 second. And then I want to print 2 next time. So I want to say increment counter. Change counter by 1. That's going to make it 2. Then we'll print the 2, make it 3, print the 3, make it 4. I want to keep repeating until I've printed my n and incremented it, right? I want to keep on going until counter is bigger than the n I wanted to print. So repeat until counter is bigger than n, let's say. And that should stop it all. So I think that will make it happy. Print from 1 to 10. It goes, making counter 1, 2, 3. See how it's changing, and it's still always 10. 6, 7. That's still not greater than 10. Still not greater than 10. Still not greater than 10. Well, now it is. Now it's 11. So we skip it and we're done. Okay. Any questions about that? That's how I might think about it. And then to solve the sub problem of like, all right, count down to negative 10. Right now it's going to just like, I guess technically it won't do anything at all. That will stop your entire loop because counter is, oh wait, really? Repeat until counter, yeah, 1 will be greater than a negative number. So technically it doesn't print anything at all if you just leave it like that. If you do it this way, that's kind of nice. Print from 1 to negative 5 just does nothing because I've already had counters 1. Negative 5 is smaller than that. So it does, we're going to skip the loop. That's already true, this idea. Okay? You could yell at the user if you didn't want to like leave them hanging, but technically this works. So it's up to you. You could also just like honor their request and be like, all right, if at the start it's smaller, then let's make the increment negative, something like that. It's completely up to you. That's hopefully making some sense. That's how you write programs, in essence. That's how you think about them. Any questions about any of that stuff before I switch gears to a new topic? All right, one thing I do want to show you, I don't know if we have enough time for this one, but I want to show you how to make custom blocks, and we're finally going to solve the problem of Pong, and it was bouncing in the wrong way, so let's fix that. All right, so let's make our own block called if touching paddle bounce. That's a thing you can do in Scratch that we haven't done yet. So the whole goal of this class is to learn how to break down problems, at least especially of this lecture. Break down problems into smaller pieces. And sometimes it's nice to make a block for that. Make your own block that just keeps track of doing all this fancy stuff, whatever it means to do all that. Break down problems into smaller pieces. And those smaller pieces can become blocks that you can then go and use as many times as you need to, which is super nice. Okay. So right now, when we were playing Pong, the ball came in and we had it bounce off in the exact 180 direction. And that did not look great. That's not quite how things bounce. Okay, so we'll need to fix that. Let me load a program from last time. I think it was this one. We'll find out. Yeah, so this is my Pong, and remember what was wrong with it. When it bounces, it goes and makes a 180. It shouldn't have done that. Okay, so let's fix that. Let's fix that, because if we touch the edge, we bounce. If on edge bounce, if we're touching the paddle, then we do this bouncing. Wouldn't it be nice if we could just instead of all this, which is kind of ugly, it'd be a lot cleaner to have just a block saying if touching paddle bounce, and we worry about what that means later. Wouldn't that be so cool? So let's start with that. So I'm going to remove this code from last time. You can get this if you like. This is the code from class. You're allowed to go there. That's on our canvas, right? You go to Pong. It is here if you'd like to follow along. But here's the idea. Let me steal away this stuff, if touching paddle stuff, because I want to put a block that says if touching paddle bounce right here. All right. And so this is the last piece of Scratch that we haven't been to yet. In My Blocks, below Variables, right here, you can click Make a Block, and we'll call it if touching paddle bounce. And we don't need any of these things. It's just going to be run like that. And so it's going to add this definition event block thing, and we'll deal with that in a second. But it also gives us this block now, if touching paddle bounce. Do you see how if I put this right here, it'll do it right? If I gave meaning to this block, it would do the right thing. It's like we're moving the ball. If we're on the edge, we bounce. Bam. We also move the ball. If we're touching the paddle, we should bounce. See how that'll work? If we gave real meaning to this block. Yeah. So now let's give meaning to it. So we can have as many of these blocks as we want. We can drag it out as many times as we need it. We're only going to need it once, though. But it makes this so clean looking. I love it. But you still have to worry about like what happens when you run this block. And so that is where the definition block comes into play. Whenever this block runs in your code, wherever you have it, it's going to jump up here to the definition block and run whatever code you put there. So it's like you're hiding it away somewhere else and not letting yourself worry too much about it for now. All right? So this is what it means to, if you're touching the paddle bounce, run this code. That's what it's saying. All right? So that's the definition block. And so every time this runs, every time this tries to run its own block there, it's going to jump up here and run all this code. All right? Does that make sense? That's what it means to give meaning to your own block. You have to say what to do eventually, but it makes this code look so clean. It's so beautiful. All right? So I haven't changed anything. It's still going to bounce in the weird way. It's going to do a 180. But now it's just so much cleaner to look at. That's just like beautiful to me. Isn't that great? So, all right, let's talk about how to bounce properly now. All right, so do we understand the idea of making a block, though? Like, if you make it, you have to say what it means when it runs, and this is where you do that. It just jumps up here and runs all that code. So, all right, let's figure this out. If the ball is coming this way, we do not want it to bounce off that way, do we? We would like it to bounce off that way. That's the better way. That's like, boop, boop. That's the better way to do it. And likewise, if it's coming from the bottom, if it's bouncing that way, okay, we want it to shoot off that way. That's what it means. That's like normal bouncing in a program, right? So let's figure that out. Let's figure out what math is involved here. So, okay, here's my paddle. Let's change the Y of the paddle for a second. Oh, not the ball, but of the paddle. 0. So if the ball is coming in this way, I want it to bounce off that way. If it's coming in this way, I want it to bounce off that way. So, all right. That has to do with direction. Yeah, we were messing with direction right here. We're turning a certain number of degrees. So let's figure this out. If the ball is coming in this way, this arrow, you see that? Let's say it's like negative 130 or something. If it's coming in that way, we want it to bounce off. It's coming that way. It should bounce off that way. Yeah. Let's try and like make that happen. What does that look like over here? It's coming in negative 130. It should bounce off. Oh, positive 130. That's kind of cool. All right. If it's coming in this way, let's say negative 50, it should bounce off that way, right? So what is that? Positive 50. The Scratch people made this very easy for us. Do you see how? Whatever my angle is, negative 117, if I just negate whatever my angle is, it'll bounce off the right way. Isn't that beautiful? Just make it negative. So if it's coming in negative 60, bounce off positive 60. Just take the negative of whatever my angle was. Switch its sign. It will bounce off in the correct direction. Thank you, Scratch makers. They didn't have to do that. That was nice of them. So, all right, instead of turning 180, all right, what does that mean? I would like to point in direction. Let me get rid of this one. I would like to point in the direction of whatever my current direction is times negative 1. Does that make sense? That's my current direction. Here's my direction variable. If I negate that, if I multiply it, whatever it is, by negative 1, that's the direction I want. Yeah? So if I was coming in Coming in like this, negative 130, positive 130. It's coming in like this, negative 60, positive 60. I guess technically it's always going to be negative, so you could have absolute valued it as well. That also works, but this is more generic. It works for pedals on the other side of the screen as well. So let's do it this way. So that is pretty fun. And so, all right, point in direction, whatever your current direction is, times negative 1. That is so satisfying. That's the right way to do it. Oh, yeah. And so it's always running that block. You see that? So if touching paddle, bounce. If touching paddle, bounce. If you're on the edge, bounce. That ran there. Let's always move 10 steps. Check if you're on the edge. If so, bounce. Check if you're not touching the paddle. If so, bounce. So that made that loop super easy to understand. And then we just still had to give meaning to that block, of course. We gave that up in the definition section. So that's what happens if we ever run this block of ours. And it's just like, it takes less mental effort to deal with it now. It's like, all right, this is easy to understand. And now if I ever really want to care about what this means, I can go up here and like, okay, this is the few lines that it takes to make this happen, the few blocks that it takes. Okay? Any questions about making your own block? That's pretty cool. You can make them with input as well. You can have like stuff where you give things as well. But right now, it was just a block by itself. So that's pretty fun, pretty satisfying. Are you good with that? So that's a fun idea. And then also, I would like to show you an example of making a state machine. Because we talked about state machines, and I went on about how cool they are and how easy it is to program them and how nice it is to like do it because it will ensure that your code is going to be correct. So I better prove that to you. Okay. Let's make a state machine that checks if a number that the user types is divisible by 5. All right. So let's pretend that the user types a number a digit at a time. So it's like they type in the 1. It's just like they're typing on a real keyboard. They type in the 1, and then like a 2, then a 3, type 123. So they're going to type all their digits separately. And so like if they want to give us the number 51,080, they're going to type the 5, then the 1, then the 0, then the 8, then the 0. Okay, that's that. So we're getting digits. We're getting numbers a digit at a time, and we're never sure if the user's done. We're just going to keep on checking if their current number so far is divisible by 5 or not. So that means it's a multiple of 5. Okay. So can anybody tell me like how you know just at a glance that this number is not divisible by 5, but this number is divisible by 5? What's the trick? What's the secret? Good, yeah. So like this number 30, that's divisible by 5. This one's divisible by 5 as well. It's always just check the last thing you ever typed. Does that make sense? So that'll lead to a state machine. If that ever wasn't a 0 or 5, it's immediately not divisible by 5. It's immediately not a multiple of 5. So the trick is the user is going to type a number that looks like this, and we're going to get those digits one at a time. So at the very beginning, like the user hasn't typed anything at all. The number's not divisible by 5 yet. But when they type the 5, we're not sure if they're done. So like we just have built up 5 so far. And if that was the last digit, it's 5 is divisible by 5. We'll check that. And then when the user types the 1, you see how the 1 just makes the number, like it's 51 now so far. It's not divisible by 5 now because the last number was not a 1 or a 5. So it's always the last digit. Now when they type the 0, now suddenly this number is divisible by 5 again. If we think they're going to stop here. 510. That is divisible by 5. Interesting. And then once they type the 8, we've got those numbers so far. Now this number is not divisible by 5 because the last digit was not a 0 or a 5. But once they're done, they type their last digit. They're like, oh, okay, that was a 0. And so this whole number now is a multiple of 5. Okay. So that's the trick. That's going to be our state machine. We're going to have 2 states in our state machine. We're either going to be in the not divisible by 5 state. Our number so far is not divisible by 5. Or it is divisible by 5. Divisible by 5 state. Right? At the very start of the program, the user has not typed any numbers. And so we should start out in the not divisible by 5 state because we have not gotten a number. Nothing is, the number nothingness is definitely not a multiple of 5. All right? So that's that. And then, as long as, well, I guess the user types the 5, and that means that the number so far is just the number 5. If you type a 0 or a 5 as your next digit, as your current final digit, then you should transition to the state, right? Your number is now divisible by 5. And as long as you keep giving 0s or 5s, it stays divisible by 5. So like you type the number 5, it's divisible by 5, that'll bring you here. And then if you type like another 5 to make the number 55, you're still divisible by 5. See that? So it's going to keep you there. Another 0, still divisible by 5. That's happy. Okay? There's that. And then, if you ever type a number that's not a 0 or 5, you go to the not divisible by 5 state. And you stay there as long as your last digit of your number is not 0 or 5. Okay? Does that make sense? So like running it with this example, like the user types the 5. We started here, but then we got a 5, so we moved to here. We're in the this number is so far divisible by 5. And then they type the 1 digit to make the number 51. And so we were here, but we're going to transition following this to the not divisible by 5 state because 51 is not divisible by 5. So that last digit carried all the weight. So we're over here right now. And then if the user types the 0, we're going to transition back to over here because 510 is totally divisible by 5, and we saw a 0 or 5 as our digit. And then the user types an 8. We were here, but we're going to move back here because we saw a not 0 or 5. And correctly, we will conclude that 5,108 is not divisible by 5. And then when you type the 0, it'll bring you back, and it'll all be happy. All right? So that number is divisible by 5. So we'll turn this into a state machine. So we have to somehow put this in code somehow. Encode this in code. So we're going to have to get digits one at a time from the user and have it run through the state machine. And we have to remember where we are in our state machine. So we have two possible states where we could be. We can't like draw a picture in code. We have to make a variable essentially. Let's make a state variable. And we'll represent the idea of being in the not divisible by 5 state by having our state variable hold 0. And if we ever transition to this state, we'll call our state variable, we'll have it hold 1. All right? That'll differentiate between whether we're in this state or this state. Okay? So that's that. And so the state will start at 0, and it might change though if you type the 5 or something. It'll go from state 0 to state 1. That's how we can encode which state we're in. Does that make sense? It'll make more sense with an example for sure. But that's kind of the setup. All right, that's the state machine, and that's a very easy way to check if a number entered a digit at a time is divisible by 5. So all right, when the green flag gets clicked, let's repeatedly, until the end of time, I guess, because we don't know when the user is going to stop, forever, let's ask the user to type the next digit. Enter the next digit, because we want them to type in the number a digit at a time. Yeah. And so it's the answer that's going to hold the digit. And then we want to keep track of our state machine. We want it to start out, our starting state is the not divisible by 5 state, which is state encoding number 0. Okay? So I'll make a state variable for that. I'll call this state, and I'm going to start it at 0, because that initially in the not divisible by 5 state. That's what the 0 represents. And then forever, we're going to ask the user to enter a digit, and we're going to run that digit through our state machine. So, like, we have to figure out, like, we do different things, right, depending on if we're here or if we're here. So we better have an if-else. So it's just going to turn into a big long if-then-else. So if the answer was a 0 or a 5, we do something. Or sorry, if our state was 0, we run it through this state. Otherwise, if it was 1, we run it through this state. Okay. So if our state was equal to 0, so if state is 0, that means we're in the not divisible by 5 state. So if we saw a 0 or a 5, we go out of this to a 1. And if we saw a not 0 or 5, we stay in our current state of 0. Okay? So if we're in this state, we have to run the state machine. And likewise for this state. If we're in state number 1, we'll hit the else part. You see that? We'll hit the else part, and then we'll have to run it based on that. If we see a 0 or 5, we stay here. Or if we see a not 0 or 5, we're gonna transition our state. All right? So that's going to be a little complicated. Let's figure that out. So if state is 0, that means this is my state right now. So let's look at the input. Either it's a 0 or 5, or it's not a 0 or 5. We'll have to differentiate. Okay? So to do that differentiation, it's going to be a bit ugly. You need another if-else. Does that make sense? So if the answer, right, that's the next digit that we got, if the answer was a 0 or it was a 5, we better be checking. So if answer was 0 or it was a 5, so I'm going to have to duplicate this, or it was a 5, and I'll have to OR them with the logical OR operation. So if the answer was a 0 or the answer was a 5, disgusting, I know. I'll zoom out. Then that means, all right, if state was 0 and this was true, that means I'm here and I saw a 0 or a 5. So that means I should transition to state 1. Does that make sense? So I'll change my state variable to reflect where I am right now. So state needs to be 1 because I just saw a number and it is now, I know it's divisible by 5, even though it wasn't before. So that's just change state, or sorry, set state to 1. Now it is divisible by 5. All right. Otherwise, if I was in state 0, and I'm running all this, and it wasn't a 0 or a 5, I'll hit this one. All right. So that means I was here, and I saw something that wasn't a 0 or a 5. So that's here. So I stay in state 0 if I do that. See that? And then I'll stay in state 0. Set state to 0. Technically, it's already 0, so you can keep it like that, but that's fine. All right. So that's the trick. If you're in the not divisible by 5 state, then you're here, and we've transitioned in or out of that. And alternatively, if we were in the divisible by 5 state, if state was 1, then we'll go down to this else. All right, and then we'll have to run it here. So, all right, what happens if we're in this state? If we see a 0 or 5, we stay there. Otherwise, we transition to the state number 0, the not 0 or 5 state. Okay, so this is how I'm programming it. And so if you think about it long enough, it's actually the same thing. So I could have cleaned this up a whole lot, but that's okay. This is a good starting point to understand it. So otherwise, all right, if I am in the other state, it's still the same way that I'm transitioning. If I see 0 or 5, I'm in state number 1, even if I already was there. So set state to 1, otherwise set state to 0, and that's going to be the process. So technically, because you duplicated this, you don't need this outer if-else. It didn't matter which state you started in. But this is essentially reading off the state machine. So this means if I'm here, then this was the 0 or 5 state. We were in the divisible, or in the not divisible by 5 state. And if we ever got to here, this one, this means that we must have been in the else case. We were in the divisible by 5 state. All right, then I'm running it, and slowly but surely it's changing my state forever and ever and ever until I'm done typing stuff. So that's my game. Enter the next digit. Oh, what was it? 51085. Oh, sorry. Let me check the state so that we can see where it is. So enter the next digit. 5. Okay, it's currently divisible by 5 because state's 1. 51 though. I typed 51. Now state's 0. 51, 0. 510. Now I've typed 510. The state is 1 again. It's now telling me that number I've typed so far is divisible by 5. And then I type in 8 to make 5,180 or something. And then, okay, cool. State is 0 again. And, oh, sorry, I forgot the 8. 8, still 0. And then one last 0 to make whatever that number was that I typed. I think I didn't type the 1 correctly. But it ended with a 0 or a 5. And so the state machine correctly told me that it was divisible by 5. All right? So this is me like reading off the state machine and translating it. I think you can imagine that you can clean this up quite a bit, though. All right? But are there any questions about why I did this? How I translated this drawing into code? We need a variable to keep track of what state we're in, and then the transitions were just if statements. Like, was this the input? If so, I need to move here. Was this the input? If so, I need to stay here. And what does that mean involving your state variable, etc., etc. But that's your state machine for that one. We good with that? Did I just save that? I have no clue. Save. Cool. If we are happy, I have one last question for you. So here's my, you don't have to code this. Do not try to code this. It will be hard. But see if you can figure out, or at least draw. I'll give you a few minutes to think about it. how would you create a divisible by 2 state machine? Because if the user typed a number like this, like 1,234, a digit at a time, how would you know that like this number is divisible by 2? It's a multiple of 2, isn't it? And so is like 12 is also a multiple of 2. 123 is not. Could you do something like this? 5 is kind of easy. This one's a bit harder, right? It's going to be an easy state machine, but it's harder to program. This is where state machines shine. See if you can figure that out. Do you see it? What digits determine, what ending digits determine if a number is divisible by 2? Divisible just means a multiple. Like, how do you know that, like, 18 is a multiple of 2? 510. Yeah, it's the last digit. Which ones are important here? Yeah, even ones. So if it's anything, 812, etc. All those numbers divisible by 2, even like 46, etc. You get the idea. What's the secret? Well, just like this one, you could break it up into 2 states where you saw your last digit was, like, let me go back to blue, I guess. You could break it up into 2 states. If you just saw a 0, 2, 4, 6, or 8, yeah, as your last digit, or if you just saw a 1, 3, 5, 7, or 9 as your last digit. And you just move around between those. Does that make sense? So that's a similar idea, and this generalizes pretty well. It's one good thing that state machines are for. So yeah, if you can draw this, you can implement it. I believe in you. And that's one way to do math stuff with state machines. That's how you program them. Any questions about that? A fun little exercise, a little complicated, but the alternative would be like, how do you even start? All right, if we are happy, what do I have to do still? Did I save this? I think I just saved it, hopefully. What I'd like to do still is tell you about a programming assignment. This one will be due in a few weeks, week 9. So lots of time because there is a test as well. So let's talk about your next programming assignment. This will be your last Scratch programming assignment because we're about to end Scratch. So we'll finish it with a bang. So if you are in the group that has been doing the Scratch assignments, I would like you to just make a program of your choice, whatever you'd like to do. So be creative. You can implement anything you want as a Scratch program, but here are the requirements to make sure like you're doing something like meaningful and significant. So your program, whatever you make, could be of any design that you want. You can make an animation, could make like a mathematical calculating program, doesn't matter. Your program, it needs to have at least 3 key press events. So like your sprite should like move when the up key is pressed. That's like a key press event. So you need 3 separate key press events doing different things somehow in your program. Maybe you'll make a game or something. That's a common thing. You must also use at least 2 conditional blocks. So like if then else or if then by itself. You need at least 2 of those blocks that check something. So I'm forcing you to use the pointy conditionals, pointy Boolean expressions. So like check if the ball is touching the paddle. That was like something I checked in if else statement. Yeah. In Pong. Your program must also use at least 2 looping blocks. So at least 2 of those, like a repeat and tell and a forever, or 2 repeat and tells, etc., etc. Like that's important. So like the ball in Pong was moving in the current direction forever. That was in a forever loop. Okay, until we stop the game. So yeah, those are the hard requirements for your program. You also just can't like directly copy one of my programs. You can't just like recreate Pong or something. That would be too easy because I gave that to you. But you can totally build off my examples. Like maybe you could make two-person Pong. That's totally a possibility. Or just make your own new platformer game with actual platforms that you could walk on top of. That might be fun. It's like a bunch of check if you're touching the platform or something things. But yeah, you're allowed to do whatever you want. And as usual, please upload a video where I can hear you explaining your program. And since this is like you have free reign, I have no clue what you're implementing. It'll take a bit longer for you to explain it and show your code to me, I think. So just keep that in mind. But make sure that I can hear you explain it. Because I want to know that you didn't just blindly copy it from somewhere. Okay? So that's your program. If you are working with Scratch, any questions about that? Does it make enough sense? You can do whatever you want. As long as you follow those guidelines. Alright, and then for those of you who have been doing the other assignments, if you've programmed before, here are your last 2 chapters to read or sections to read of this book, and I'd like you to do these 3 exercises, please. Alright? And if you want to do something custom, you can always talk to me. So that's that. Those are your assignments for those programming assignments. And this will be due week 9, so you got plenty of time to think of something and come up with something good. Questions about that? Alright, so that's your programming assignment. Let's also talk about your midterm. You have a test coming up soon. We're in week 6 right now. So I promised a midterm in week 8. Alright, so I am releasing, not the midterm itself, but a midterm info page on Canvas. So just like below our current week module, like you're not going to see these are hidden to you, but you'll have a midterm module. Alright, and eventually the midterm itself will be there. You'll click it and start taking it. But let's talk about the midterm info. Here it is. The midterm will be during class on February 28th. So here we are, week 6. The last possible day that we could take the midterm is week 8. In week 8 is the Wednesday, so that's when we're going to have it. All right, you can have as long as I'm giving you, as long as I can possibly give you. So the 28th. So in exactly 2 weeks, you'll be taking the midterm in class. That's all we'll be doing that day, and it will cover all the topics we've been talking about up to and including week 7. All right, so next week will be the last stuff that could be on the test, and most of the points will go towards you writing an essay question. All right, one thing I cannot do is, sadly, I'm really sad about this. In the final, I will definitely be doing this, but I cannot for the midterm really ask you to write programs in Scratch because, like, how do you submit it on Canvas? You can't like record a video while you're taking the test. Makes sense. So I won't be asking you any Scratch programs on the midterm, okay? Instead, any non-essay questions will be dealing with this little cheat sheet, all right? So let me talk about the format, and then I'll show you this cheat sheet. So the midterm will have a few multiple choice questions and short answer questions on topics from this cheat sheet, wink, wink, and then also I'll ask you to write a short essay on some topics that we've been covering in lecture, and this will count towards your 6,000 words you're forced to write in this class, so we have to do it. All right, so be ready to write an essay, be ready to do some short answer kind of questions using topics from this cheat sheet. And here it is. Oh man, this is too complicated. So wink, wink, expect questions on these operations, etc. Okay, so that's that. And finally, the test is completely open book and open notes, but I'm writing the test with that in mind. Right? The only thing you can't do is talk to another human. Like, don't talk to AI, don't talk to somebody on Discord. You can ask me questions about the questions, of course, but I'm the only other person you can talk to as you're taking the test. So it'll be on the 28th, that Wednesday, in class. Any questions about the midterm? Did I answer all of your questions that you might have had? All right, so that's when it'll be, and I'll have this released. I guess the date is correct right now, but you'll be able to click it, and then just like a timer will start ticking for the amount of time we have in this class. So that's pretty much it. So yeah, any questions about any of that before we wrap up? Remember to do attendance. I'll stop that right now. If we are happy, I think that was everything that I wanted to say.